Okay, I'd like to give you some help with coding the Qs and some FileIO help for the assignment number 1, which is going to be assigned today. So first things first, let's go open up Visual Studio. Okay, you can use whatever version of Visual Studio you're most comfortable with. Okay, console app. Say next. What we're going to do is we're going to call this one Qs. So this one's going to be Qs. Put this one on the desktop. Let's go to desktop. I have some, I'm just going to call this one Qs. Select folder. Oh, it's already going to call it Qs. So say create. Okay, and what we're going to do is we're going to take the code from the lecture and we're going to implement it. And the idea here is I want you to be able to follow along and also to get accustomed to multi-file projects. Okay, so I don't need this. This is going to be the Qs project. So this is the main line. We're going to call this main line for the Q functions. Okay, so the idea throughout this course, okay, you're going to have code. You're going to get, let's say, Q functions here. So you're going to test them with your own main, the functions for Qs, and then as we go, especially in the project, you're going to combine the functionality from different projects into, or different labs or assignments, into one large project in the project. Okay, if you're in the project. So the idea is we have main lines to test our functions, to test the functionality of our functions. Once they're known good, we don't change them, and we bring the functions, the Qs functions, let's say, or that functionality, into our project or into our assignment, let's say. So I'm going to show you we're going to build right now a main line for testing the Q functions. Okay. All right. So here we have main. I don't need any of this. I'm going to get rid of all this stuff. All right. So we have our main. Okay. So we're not writing a C++, but we're using CPP. It doesn't really matter. So we're going to include standard IO. Okay. So usually we need standard IO at least, standard library. Right? We need standard library. We need to allocate memory, so we need malloc. What am I saying? Include malloc.h. Okay. And then we have a Qs, so include, and it's going to be Qs, Queues .h. And we haven't created it yet, so it's going to say that there's an error. All right, so what we need to do is we need to go into our header files, go add, new item. Okay, it's going to be a header, and it's going to be called Qs.h. Queues.h. Enter. Okay, and in source, I just want to see, this is Qs.cpp. This we need to rename. I want to call this, because I need a Qs.cpp, so I need to rename this. I'll just call it main, and then change the name. So we'll just say main, and then we'll just say main right here, Control S, because we need to create a Qs.cpp. So we're going to go add a new item, and go here, call it Queues.cpp. Okay, so now we have Qs.h, Qs.cpp. Okay, so Qs.h, what we're going to do is we need to take all of the function definitions that we saw in the lecture here, and we're going to actually start implementing them here. Okay, so we have, let's see, if we look at, we have in the assignment, if you go and look at the assignment, we have a certain structure that we need for it. But first, before I start any of this, let me go in here and space, there we go, like this. Okay, and we're going to say this is Qs.h, and this is the interface for the Q functionality. Okay, and then you could, I don't know, by author put your date or whatever you like. I'm going to still have my pragma. Once I should put the hashtag in front. Okay. So inside here, what do we need? We need, okay, let's do our type defs. Type def struct. We have node, and we're renaming that to node. We haven't defined what struct node is yet, but we will. Type def. We want struct item as item. We haven't defined struct item, but that's okay. We will. Type def node, a node pointer to a node, right? And we're going to call that link. Okay. And now we have to define item and node. So we have struct item. This is where we define what it looks like. Okay. And then we have struct node. We're going to define what that looks like. Okay. And we know node is link p next. Okay. And we know that link is a pointer to a node, right? And a node is struct node. Okay. So that's what that is. So this guy p next is a pointer to a node. Okay. And then item we defined as struct item. Okay, this is going to contain, and the variable that we use is data here. Okay, so it's of data type item, and we have the variable data. Now, what does a struct look like? Now, this depends on your application. For the application that's in the assignment, so that I'm going to kind of add a little more than what we saw in the lecture. Okay, so here we have car message. Okay, and this is going to be of some length. Now, this has to be a constant. Now, if we look at the assignment, we see that the length of the string that we're pulling from the file must be cut off at 140 characters. So we're going to say const int I length is equal to 140 characters. Okay, so we're going to so save that, and basically the message is going to be I length long. Okay, Control S to save, and it's all good. All right, now inside the assignment there's a set structure that you might consider using. So let's just go with what's in the assignment. Short int SID. Okay, and what's this? This is the sender ID. Okay, you can always change this. Okay, so but for now, short int, and this is our ID. This is the receiver ID. Okay, this comes from, we're sending messages between senders and receivers, and it's not okay. Let me just fix this. All right. Okay, and the next thing we have maybe a priority scheme of some sort. Priority. It could be a character. It could be, this could be a number, an 8-bit number. Okay, so this could be priority. Again, this is just an example. Okay, we have a short int sequence number. Sequence number. This is the sequence number of the message. If you want one, this is something that you'll learn a little more in Datacom in semester 6. What's a sequence number? But this is just some things that we can put in our node. And then car, something we can have for later. Just put 25. Okay, so this is just something character array that we can use later. Okay, something like that should be enough. Okay, so we have that, and then we define our function prototypes, our Q function prototypes. Okay, if I could type, it would be great. All right, so Q function prototypes, we're gonna go void init QUEUE. It's good. This takes nothing in as an input. Okay, so we have that. We haven't defined it, so it's underlined. It's going to be anyway until we define it. It's not going to. Okay, so is QUEUE empty. Okay, and then this takes a void. This just looks into the queue. Okay, and then we have void add to QUEUE, and then we're passing a link to something that we've created to add to a link to the node that we've created that we want to add. And then this guy's going to return a link when we dequeue from the queue. It returns a pointer to the node that we've dequeued. That was the head. The head that is no longer the head. Okay, so control, save. All of this is so far good. I'm going to copy these prototypes. Control, actually, let me do this. Let me grab this, control, copy, go into Qs, and this is the implementation for the Q functionality. It's dot .cpp or dot .c, whatever you like you can use. It depends on the file that your file type. Okay, and then here we want to put the implementation. So we'll go back to Qs.h. I'm going to grab the prototypes so that they're all spelt exactly the same and I don't make any mistakes. I have to go to Qs.cpp, go here, and convert them from statements to function definitions. Okay, and here as well. Okay, now here, it doesn't know what link is, it doesn't know what this return type is, so I have to go in and I have to say include, where am I here? I have to go here and say include, okay, Qs dot h, so that it knows what the data types are. Okay, and probably we're going to have some IO stuff, and we're going to, so we need at least the standard library. Let's just make sure we have that. Okay, and then we're good here. Okay, so now we have our, now you can put above each function, you can put a comment on what the function does. Okay, so I'm going to leave that because just to save some time. I don't want this video to be too long. But you can put what they do. Okay, so now what we're going to do is we're going to go in and start defining these. So static link, and we have p head and p tail. Okay, so these are the pointers to the head and tail of the queue. In here we have p head. Okay, so initialize the queue, it's empty, so p tail, and then they equal null. Okay. Null is a constant that's defined in standard library. So this initializes the queue. Here we're going to check if it's empty, so return whether p head equals null. If p head is null, then it's empty. Okay, so those are fairly simple. Now we're going to add to the queue. So there's the cases when we add to the queue. So add to queue, it takes a link. We actually need to save that somewhere, so we'll put it in pointer to a node. Okay, then we'll say here if, okay, is queue empty. We call the function. If it's empty, then what do? If we're adding to, then that becomes the head, right? So that means p head equals, it also becomes the tail, right? For that case, equals pn. The thing that we want to add to the queue, that becomes the head. Okay, so we pass a pointer to the object that we, or to the node that we've created. Else, okay, if there's already something in the queue and it's not empty, then we can add to it. So then we can say p tail. Okay, what p tail? This is the thing that p tail points to. Okay, so p tail is the pointer. Okay, with the arrow it means the node that p tail is pointing to, and it's p next. Okay, so that's a pointer now, equals pn. Okay, so the old tail, right? I'll put this one in. Old tail now points to pn, the node we added. Okay, this is important. Okay. Then what else? Then p tail, right? P tail, right? Now equals pn. Okay. So now we make p tail ptail points to pn. Okay, so ptail is the pointer that keeps track of the end of the node, right? But what ptail pn is, that's the last node's pointer. Instead of pointing to null, it's pointing to pn. Okay, and then at the end, once we've added it, ptail arrow p next, okay, equals null. What that means is the last item in our list, regardless of what we do, is now pointing to null. Okay, the tail is always pointing to null. Whether it doesn't matter which of the two situations occur, we make that always point to null. Okay, the last thing we have to define here is to dequeue, right? So how do we dequeue? So we say link p temp. Okay, so this guy is going to hold the current head, right? The head of the list right now before we dequeue anything. So then we check if is q. Okay, you can push. Oops. Go here. Is q. Let me do that again. Is, there we go. Enter. Is q empty? It's a function. If it's empty, then you can't dequeue anything, so just return null. Okay? You can't get anything. Else we can. Okay? So now we're gonna say that p temp is pointing to p head. So this is the thing that's going to change. The p head is going to change, so we need to store it somewhere. This is the thing that's going to be returned, right? P head is returned, right? And then changed, and then incremented to next item, to next node in list, right? So we have to store it somewhere. Store the head. P head. The new head is now going to point to where the first item pointer, the pointer to the next item, is going to point to that one. It's going to point to the second item. So we say p head, the current p head, it's p next. Okay, so this p head is a pointer to the head. This is what is stored inside there, and then this says this is the actual pointer to the next item. It's basically the pointer that points to the next item, the one that comes after head. Okay? So what we're saying is this next pointer becomes p head points to next node in list. Okay? Okay. So that's that. Let me see what's going on. Control S. P head, it should be. Where is p head? It's in here. It is up here. Okay. So that's that. And then we're going to return the old head, which is now p temp. And that's it. This is original head. Okay. P temp. And that's it. We're ready to go. Now we need to make the main to test these. In order to test these functions, we need something to test. Okay, so let's play around a little bit. So let's say we need, let's see, what are we gonna do? We need pointers. So link p. Maybe we need 2 pointers. Let's say. Okay, we need. We're gonna have a for loop, probably somewhere. So let's just do that. I always use a for loop. Okay. First thing we need to do, init queue. Initialize the queue, set everything up. Then we need to add items to the queue. So let's do a for loop. And in this for loop, is less than, I don't know, how many items we want to add? Maybe we go 10? 10 items. Some round number. Okay. And then how do we create items? So we create items, we create the we declare the variables in main, and we pass them to our Q, right? So P is a pointer to a node, equals, and we're going to malloc, but I need to cast to a pointer to a node. And what's the size? We need the size of, we need to look for space in memory, the size of a node, right? And P is going to point to that space, the free space in memory that does that. And then what we're going to do is we're going to make store something in the data. So let's go P. What P points to, okay? It's data. Let's go to its. Oops, sorry. It's data. Let's click that. It's data, and the data has what? It's SID. Okay. Equals I. So we're gonna, if we go back to here, where is it here? Sorry, the definition. So we go into, so item. So look, data, right? And then SID. So remember, we always use the variables when we look for it. So this is P is the pointer. This means what P it points to. This is dereferencing what it points to. It's like saying what P points to dot, right? If I went to, so P is a node, right? If we went in here and we created a node, it would be that node's name dot. It's another way of doing the same thing. Okay, right? It's like saying this is equivalent actually to this. I'll show you. It's equivalent to star P. Okay, so we dereference that dot data dot SID. Okay, that's the same equals I, right? Because we're saying dereference what's at P, right? Dereference this guy dot data dot SID. Actually, it should be like this is the way to go. Yeah, like that. Okay, so it's dereference what P is pointing to. That's a node, right? P is a link, so when you dereference, it's a node. The node dot data dot SID equals I is the same idea. Same. We can play around with that after. We'll check. We'll make sure that that's correct. Okay, and then once we've created the node, P points to that node. Now we can add to the queue. We can add P to the queue. Right? And that's it. So now we've added these things to the queue. And the next thing we're going to do, so this is add to the queue. Add nodes numbered 1 to 10 to the queue. Well, it's add. It's create and add, right? Create and add nodes numbered 1 to 10. Should call them like that. Okay. All right, and then once we've done that, then we can actually print them off, dequeue them and print them off. So now we'll say while, right? While it's not empty. So while is not, right? Is queue empty? I could just click there, push enter, function. While it's not empty, then queue. It's going to so the dequeue is going to return a pointer, right? Q is that pointer. Is dequeue. So we're going to dequeue a node from it that's stored in queue, and then we're going to print we only have the SID. That's the only thing that has data in it. So we'll just go \n SID of node. Let's say %d is, and then I'll actually, you know what? Let's just say SID of node is, and then %d, because it's the same order. It's not gonna change anything. Okay, and then go here, and then we say Q. What Q points to, right? The data dot SID. And then we'll go like that. And we're saying that that is equivalent to star Q dot data dot SID. Right? We're dereferencing what it points to. Right? Same idea, but we'll check it out. Control S to save. This is main, so it must return something. It's int main, right? So return, I don't know, we return 0. Okay. Control S to save, and we can start testing our code. Let me open this up a little bit more. Let's go here, say Windows Debugger. See if we have any errors, because this is, we're testing our code, right? So right now we have, okay, nodes 1 to 10, okay, 0, because we start at 0. So 0 to 9, everything works and it's dequeued basically, right? Because then it's empty and then it ends. So that's good. That tells us that. Now let me just test out this thing right here. Control C. What I'm going to do is, actually, I'm just going to do this, and do this, and just go like that. Okay. So we'll just test out my thing just to make sure I'm not making any mistakes. And no, I didn't make any mistakes. So good. We could do the same thing with this guy too if we wanted to. But anyway, same idea. So I'm gonna go back to the original. This is the way I did it here is a little better. Okay, so that's Qs. This is how you get your Qs working. Okay, so that's one project. I want to show you one more thing, FileIO stuff. I'd like to show you some FileIO because we need to do that, and I'm going to give you, it's a starting point for the assignment. Okay, just to give you an explanation. So I'm going to close out of this one, and what I'm going to do is I'm going to give you a starting point for getting your. I give this to you, but it's a starting point for your project. Okay, for the FileIO that's in your project. And in order to do that, what you need to do is go and download from Econestoga the fortune cookies file. Okay, so that's one thing we need, because we need to do FileIO with this guy. Okay, so we're going to put this guy in our project when we create it. So let's do that. So first thing is go in and well, we're basically going to start doing some FileIO stuff. So what you want to do is okay, let me close this off for a second. Say here, I'm just closing out of everything we saw before. Okay, so let's open up Visual Studio. Okay, we're going to create a new project. It's going to be a console application. This one's going to be FileIO. Okay, it's going to be on the desktop, and we're going to create. Okay, so this is going to be our file. Now, I have to make sure that this guy is in the same location. Okay, so let me go here. Fortune cookies is going to be in here. Okay, so I'm putting it inside that file so that it has access to it. Alright, so we don't need any of this. We don't need any of this. This one is going to be called, well, we could leave it as file. Well, no, I'm going to change it, rename it to main. It's going to be the main line. This is the main line for the client for main line to test FileIO functions. Okay. All right. So when we do this, we're likely to need. We're going to need standard IO.h. We're going to need standard library probably. Include. Okay. We're going to have random numbers be generated, so we're going to need to include time.h. Okay, and what happened? Why null reference here? Null reference. This may be caused by an extension of some sort. Okay, we'll deal with this one after. Let's just see if we can continue without any issues. Let's go return 0. Okay, Control S. Let's just try running this and make sure there's no issue. Okay, no issue. Okay. All right. So time, and we also, okay, so what are we going to do? We need to get stuff from our file, right? So first thing we need, now I give you a way of getting, so we need to get a random number between a minimum and a maximum number. We need a number of quotes. We have indices of those quotes, and we have quote lengths. Okay, so we basically we need to go through a file, get a message from that file. Before we can do that, we need to index that file. Okay, so that's the goal that we have to do. So let's take a look. Let's go in here. We're gonna have, so we're getting a random message, right? So I might as well call this a new item. I'm gonna call it message.h. So this is we're getting a random message, right? So message.h. Okay, and then I need message.cpp. So go here, message.cpp, and then add. Okay, make sure FileIO has. Now we might need this to be in where the executable is. Usually we do. So let me actually take a copy and put it in where the executable is, because it's going to be looking for that file once we start looking for it. Okay, once we look into it. Okay, let's close this out. All right, so let's so this is the main, this is message.h. Let me go in here and do the same thing. We want to put our comments. Okay, and here this is going to be our interface. So it's message.h. This is the interface for the message functions. Okay, we're getting text messages, right? Text quotes from a text file, right? All right, so this is it. You can put your name or whatever you like here. By Michael, okay, etc. Okay. Control C, take this, put it in here. So this is message.cpp. This is the implementation for the message functions. Okay. So we have a main, doesn't do anything yet. Message.h. So what do we need to do in our so I kind of give you guys some hints on how to do this, how to get random quotes from a file. Okay, so what I recommend that you do is, okay, the first thing we need to do is quote length. Okay, how many characters maximum? We said 140 characters. So we can use a constant or we can use a define. I'll use a define this time. Max quote, max quote length is 140. Okay, and then what I'm going to do is I'm going to do the function prototypes, right? Function prototypes. Okay, the first set, what I recommend you do is index the file. Okay, so basically, look, we've got a function that gets it gets a random quote from, now I give you this, fortune cookies dot text. Okay, and I tell you how it has to. Well, I don't tell you exactly what it has to look like, but well, sort of. You can actually modify it. Get message from file. Okay, so this guy, this get message from file. Okay, it has to store the text message or the quote in a buffer. So we need a pointer to a buffer, right? A buffer. It's a character array, right? So it's a pointer to a character array. I would call it buff. Okay. It needs to know a length. Okay. we need a length for that quote. Okay, what is the length for that quote? Okay, and if it's greater than 140 characters, we cut it off. If it's less, we cut it at the quote, the length of that quote. Okay, that's why we need to know its length. Okay, now we're going to make some helper functions in order to get the length of each quote. Some of them are greater, some of them are less. We got to know what to do. Then we need to know, okay, what is the random, what's the quote number, right? So this is a rand number. Okay, so we need some random number generator to get a numbered quote, right? So we have to have the fortune cookies file indexed in some way. We need to know how many quotes there are in the fortune cookies file. So num quotes, because we could change the file, right? We want to index that file before we do so. We need a list of pointers to the quotes, right? We need to know where to go in the file. So we'll use a long, we'll use a long because we don't know how many characters. It might be a lot of characters in the file. It might be a huge file. So long int with quote indices. Okay, and then we need a pointer to an array with the quote lengths. Okay, and this is going to tell us. So we need it's an int point quote lengths. Okay, so this guy. Okay, so we need to make functions that one is going to generate a random number. Okay, so we have a buffer. Okay, we have a length. Okay, we have so this is our quote length. This is the random number of the quote. This is the total number of quotes in the file. This is the indices of the quotes in the file. Okay, and then these are this is an array with all the lengths of the quotes in the file. So at the end of the day, this random number is going to go into here in order to give us ilen. Okay, but because the file, we could potentially have different files, and we want our function to be able to do everything. So what we need now, what we need to generate is we need to be able to generate a random number, right? Sorry, we need to give a length of the quote, and that's going to come from the quote lengths array here, right? We need to know we need an array of all the indices in the file. We need the number of quotes in the file and a random number. Okay, we're going to build these function prototypes. These are the helper. You can call them helper functions if you like. To the get message from file. Okay, so these are the helper functions. All right, so we need a function that does okay, it's got to return a random number. So f rand num. Okay, and we need to return a number between a min and int max. We need it to be between a max and a minimum. Okay. Then we need to find out how many quotes there are in the file in order to get the max number, right? So that is int f num quotes. Now I could provide the name of the file. Okay, this will be, if you wanted to, you could put in a file name, but for now it's a same file, so I'm not going to go to that extent. And then I need, again, remember I said quote indices, so long int point. So this is an array of long integers. F quote indices. So I need to index the file, and then int num quotes. Okay, why do I need to pass num quotes? Because I need to make an array that's so I need to go to this. Okay, I need this function to figure out how many quotes there are. I need this function, this number of quotes, to make an array of that size with pointers to certain locations, right, where the quotes start in the file, right? And then I need so I need an array where they start, and I need an array of their length. So this one doesn't have to be, they're not going to be that long, the quotes, so I can make just a regular integer is fine. F quote length. Okay, and I go int num quotes. So I need to, again, know how big the array has to be, this quote length array. And then I need to store in there the location, right, of the indices. I need to pass the indices because I need to know where to start and stop for each quote. Quote indices. Okay. All right. So these are the helper functions that are going to help us get the functions from the file. Okay. So what do we need to do? Let's go in and see. Let's see what we need to do. Let's go in main, and before I define the functions, I know what I want them to do. Okay, so let's see what I'm gonna do here. All right, the first thing is I need to include message.h, right? Because that's something that include, and then message.h. Okay, Control S. Okay, so that's one thing. Then what I need to do is I need to put in all of these variables. I need something to store the number of quotes in the file. Okay? All right. Right. So then here, this guy, this num quotes, is going to be, well, I don't even need to do that because I have a function that returns the number of quotes. So really, what I need to do, what do I need to do? I don't even need anything, really. I just need to call getRandom, right? What does this function do? Let me go in here. This guy is going to return an integer. Okay. This guy's going to return an integer, and it's going to write to buff, right? It's going to tell me yes or no. If it's okay, so really all I need is the output, right? I just need this, and I need buff. And buff, right, so I need buff. Buff is going to be, right, so I go in main. I've got max quote length here already set up. Save everything. Let's go to, so I have to create a buffer. So car, we'll say test buff, and it's max quote length. Okay, so we make our buffer here. Control S. Max quote length. Is it not included in here? It's 140. Expands to 140. Expected expression. Did I miss something? No, it should be right. Yeah, should be right. I don't see what the issue is. Try to run it and see. Build error. Why? Okay, I tell you what. Max quote length. Max quote length. It's telling me that there's an issue here. It's telling me that makes no sense. Oh, because I put the equal sign. Sorry, guys. I used it as a constant. Okay, so that's why there's an issue. All right, Control S. All right. Sorry, I missed that, but anyway, okay. So now we have a buffer, and we want to be able to write to our buffer. Before we do that, okay, first thing I want to do is be able to read the file and figure out how many quotes there are in the file. Because, look, so let's go here. I need an int result. We'll set it equal to 0 for now. Okay, fail, and then we'll say result equals, and what we're going to do is we're going to use this guy right here. Right? Control C, So we need to figure out what all these things are going to do. So this is the buffer. So what we're going to do is we're just going to pass test buff, right? The name of the array is a pointer to the first element. ilen, we don't know what ilen is, right? Okay, we can get rid of int ilen, we can get rid of int, get rid of num quotes, quote indices, and quote links. Now, remember, this guy, right? So look, random number, we're going to call f rand num function, right? And it's going to return a value there. Now, wait a minute, what's it expecting here? Let's just make sure we don't mess it up here. We have f random, and we need a min and a max, right? So min is going to be 1. We need 1. We need that and, so a rand number between that and the number of quotes, right? So where is, we have f num, we need something that's going to give us the number of quotes. So f num quotes. So f num quotes. F num quotes. Did I spell it right? Yeah. And it takes nothing as an input. Okay, so we need a number between 1, the first, and the number of quotes. Okay, so that's that one. And then we need f num quotes. We're going to pass that over to it because it's probably useful to pass that information. And then we need quote indices. So quote indices, this guy needs f quote indices, and then we need num quotes. So actually it might be easier if we say num quotes, right? So let's do this so that we don't have to keep calculating it. Int num quotes equals f num quotes. And then do like that. And then we don't need to call the function anymore. We just use the variable. Just in case, right? And then we have then we need f quote indices. Okay, we may want, yeah, you know what? Let's do the same thing there. So we have num quotes. We need quote indices. Okay, let's do this. Copy this. I want to keep everything separate. Okay. So num quotes. Let's do it all once. Okay, so we have num quotes. We have quote lengths. So int star quote lengths. Okay, we have test buff here. That's fine. Okay, and then we have result already there. We set it to 0, no problem. So we say here is count. Here we need to count the number of quotes in the file. Okay, we only need to do this once. Okay. Alright. That's good. And then what we can do, before we start doing this, let's start testing we're going to have to build the num quotes thing. Here we'll just go printf, and then we'll say there were %d quotes in the file, and then we'll say num quotes, close that off. Probably I want to put things on the new line all the time. Okay, so that's that. Okay. So let's do that first. We'll test everything out, and then Control S, go to message. So we got message.h. We need a random number, and it ran quotes. Okay, before I start doing anything, all I want to do is test this guy right here. Okay, so now I need to define f num quotes. First step in the process right here. So let's go f num quotes, go here, Control S. Now we got to figure out how are we going to count the quotes in the file. Okay, there's there's a couple of different things that we're gonna need to do. So first thing, what file? Okay, so we need in standard. So we need to have include standard library.h. We're gonna need to make space for stuff, so we might as well include malloc.h. Let me just do that properly. Okay, malloc.h. We might need some. Okay, let's go to, and we need message.h because that's right. Include. We'll just include it for good practice. Because we might need some file constants or stuff like that. Okay, so we need to count the number of quotes. Okay, we need, first of all, we need a file. This is a type. Okay, this is a file pointer. It's a data type. FP. Now, if it's not found, then we're missing something. We got the standard library. We've got malloc. Oh, you know what? It's defined in here. Include .h. Okay, let's see. Does it not have the file type? Right. Okay, we're gonna have to find out which of the headers are going to give us the file type. Okay, so if you go underneath that, the file, if you go to show potential fixes, it says add include C standard IO. I could just go standardIO.h and see if that will, I'm not sure why, but tdio.h, is it defined there? Control S? Yes, okay. So, I mean, there you can use C standardIO or standardIO.h, that's more for C, but anyway, this works, so use standardIO.h, okay. So we have the file pointer. We could use this error number if we wanted to. If there is an error of some sort, we could if we want to use it, but let me see. Let's try without it first to keep things nice and simple. So we're going to get one character at a time from the file. Okay. And then we need a counter for how many characters we get. Okay. And then let's go with the error. Let's use the error. So what we're going to do is say error. No, it's a data type. ERR. Okay. Okay. So then what we do? We're going to open the file. Okay. And if there's an error, then we're going to do something. We're going to tell them that there's been an error. So so this is how we protect. So ERR equals F open underscore S. I'm giving you the safe way of doing it, okay? We need to pass it a file pointer. Then we got to give the name. Okay, so that's fortune cookies dot text. Okay, and what are we opening it for? We're opening it for a read operation. Now, if it equals 0, okay, so the error, okay, wait a minute, make sure that the numbers are, okay, this is good. Okay, so if this, what's returned here, is equal to 0, then no error. Otherwise, we're going to tell the user, right, that there's been an error. So print f. Okay, we could put like this. We could say error. We could say failed to open file. Okay, and then \n. Okay, and then close it off, and then make sure that we close FP. Let's see something here. Wait a minute. If FP, well, FP was open, we can free that memory. Okay, So this is just to protect if we have any issues opening the file. Let's try running it and just see. Well, actually, what I should do at the end, I should always fclose fp. Okay, and that's it for now. So let's just run it and see if there's any error. There were some errors. No, I want to know what the errors are. It says here message.cpp 15 7 C is unreferenced. Okay, it was never used. Fnum quotes must return a. Oh, I forgot to return. Right, fnum quotes should return something. Here we'll just say return -1. What was the data type? It's a number. Okay, and this one should return. Oh, because we're going to have a counter. We're going to have a counter in here. Whatever the counter is, it'll return. All right, let's try it again. Open this up a little bit. See if there's an error. C is unreferenced. I know we never used it yet. There were 0 quotes. Okay, that's fine. Okay, beautiful. No error. So now we're going to start counting. So how do we count? All right, so if this happens, then we should tell the user that the file was opened successfully, right? That's the one thing we should do. So we should say file opened successfully. Did I spell that right? Okay. \n. Okay. So that's one. Print f. Okay. And then now what we're gonna do is we're gonna read the file one character at a time. Now, one thing to notice when you open the file. Okay, so if you go inside the file, there are demarcations. You see these double % signs? They tell you where the start and end of the quotes are. So what we're going to do is, if we see one of these and then we see another one, that is the demarcation point for one of the quotes. Okay, this separates the quotes. These are the separators. So what we're going to do is, if we find the first one, this is how we're going to tell. We find the first one, we look for the next one. If there's two, then we know that that's the signal for the start and end of a quote. Okay, and that's how we're gonna figure everything out. So what we're gonna do is we're gonna make a while loop. Okay. C equals f get c fp. This gets a file, or a character from the file, and we're going to, while it's not the end of file character, and this is a special character, okay, while it's not the end of file, we're going to keep looping through. Okay, so if c equals this character, okay, then we're going to look for another one, right? If there's two, then we can increment our counter. So if, right, then if f get c, now we're going to the next character. If that is that character, then at that point we increment the counter ++. Okay, then and only then. And then at the end of the while loop, okay, we return the we're gonna return counter, and then in main, right? I should open this up again. And then in main, okay, we print the number of quotes, because the fnum quotes is going to return this. So how many quotes are in the file? Okay, are in the file. That's what we're going to do here. Okay, so this should return a number if we did this right. 1141 in the file. Now, one thing that we noticed is the very first quote started with those double signs. So we did it. We counted up on that first quote. So we probably should subtract 1, right? Because that first quote surrounds it. So what we should do is go here and probably subtract 1 from it. Or we could start counter at -1. That's another way of doing it. Right? And that's it. And now we should have 1140 quotes in the file. Okay, beautiful. Okay, so that's good. So we got the first part. We've got a buff. Okay, we've got we didn't do the random number yet. Okay, how do you make a random number? We saw this last class. So frandnum is another thing that we did. And we're gonna grab a random number. So let's go here. We're gonna get. So we did this guy. We didn't do this guy. Let's do this one. So let's save. Let's go to message.cpp. Oh, actually, let's grab this guy. So how do you get a random number? We did this in class. I talked about this before. So how do you make a random number between a minimum value and a maximum value? This one's really simple. We basically return. Okay, what do we return? We return min plus, right? And or actually another way of doing it is rand. Okay, so we start off with rand, a random number, and mod, right? Max minus min, right? Plus 1, because 1 greater than that difference. And then we add min to that. Okay? So we are rand mod the difference between max and min plus 1. So this gives us a number that is the difference between max and min. And then you have to scale it up by min, right? And that gives us the number. Now, the issue with just using rand is that it never changes. So what we should do is we should seed the random number generator. That's one thing we should do. So let's see here. It's got to change. It's got to change every single time based on the time. So what I should do is we should srand, with time, no, seed the random number generator. Now, what did I do here? I forgot to include time.h, did I? So include time.h, Control S. Now I'm good. So I've seeded the random number generator with the current time, and now this should give me random numbers. Let's just, all right. So what I could do to test all this is go in here. I can do that if I want to, but I could say, where's my rand number? Let me go here. Let's go in here. I need frandnum between 1 and that. Okay, so let's go here. Let's get this guy. Control C, and we'll just say print f \n random quote number is %d \n comma paste, and away we go. Let's see if it changes every time. Some warnings are fine. 638 this time. Okay, let's do it again. 657. So it's changing. 674. Num quotes is always 11 something, so that's okay. Okay, why is it always around 6? Oh, 716, somewhere near the middle. 729, 739. So it's sort of not truly random. Oh, 762. Yeah. It's between 1 and Let me just make sure that max, so it's rand mod max minus min plus 1. Yeah. And then we add min. Yeah, this is fine. This should be fine. It's random enough. I'm just not getting any ones when I run this. Like something closer to 1. 883. Okay, that's different enough. Okay. All right. One last time. 909. Okay, we're changing enough. Okay, so we're getting a random file. Okay, so that's that. So this part is working. Now I need to get the indices to the quotes, right? The quote indices, and that is another thing to sort of look at. That's going to be very similar to the quotes, right? To when we get the quotes, we basically have when we generate this, we get the number of quotes. That same process can be used if you have an array with that many quotes, right? Or an array that contains the location in the file, right? That quote starts. Okay, so that's where the quote indices in the file. How many characters from the start of the file does the quote go? And you put that into an array for that particular quote. And that, my friends, is where I'm going to leave you to continue the assignment. So you can use the same logic, quote indices, okay? You make an array, the size of num quotes, okay? And then you can do that on the fly, okay? And then you store, the counter keeps going up. You store that in the array for that particular quote. The quote length, you're going to take the difference between the basically quote indices. The delta between quote indices will give you the quote length, and that'll tell you if you need to cut off from there. And then what you're going to do is you've got the length of that particular random quote that goes here, okay? Right? That's the quote lengths, right? Goes into ilen, right? For that particular quote. The random number is the quote number. This is the number of total number of quotes. In case you need that in here, you can probably cut down on some of these if you want. Again, it's your design. Quote indices, where they start, where they end, and their lengths. Okay? So I'm going to leave you there. I've been here doing this for an hour and 7 minutes. So the rest is up to you guys. All right. Good luck. Enjoy assignment number 1.